Hello everyone there. I, Archana M of Sri Venkateshwara College of Engineering, pursuing my graduation in 6th sem of EC domain. Today, I am going to discuss about microwave and antenna and few problems related to this topic. Microwave and antenna. So what is meant by microwave? Microwave is a form of electromagnetic radiation with the wavelengths ranging from about 1 meter to 1 millimeter, corresponding to frequencies between 300 MHz and 300 GHz respectively. And what is meant by antenna? Antenna, it is the short wavelength for microwaves allow omnidirectional antennas for portable devices to be made very small from 1 to 20 centimeters long, so microwave frequencies are widely used for wireless devices such as cell phones, cordless phones, and wireless LANs as Wi-Fi, access for laptops and Bluetooth earphones. Under microwave and antenna, there is a topic called microwave tubes. So what is meant by microwave tubes? And it is defined as it is the structure used to generate microwave frequency signal or amplify microwave signal. The microwave frequency range between 1 GHz to 10 power 6 GHz. Increased bandwidth where the frequency range is more used to transmit signal at longer distance. Improved directive properties, having less fading effects and also low power requirement. Let's see some of the applications of microwaves. So the microwaves are used in telecommunication, radars, commercial and industries and also in microwave semiconductor device. Let us see few formulas to solve the problems. The formulas are as follows. When the reflex klystron is given with an input of the DC power which gives the output as the power of an AC current. When let us see the first formula, which is efficiency. So the efficiency is defined as it is the ratio of output power to that of to the input power, which is further defined as the power of an AC current to that of to the power of an DC current into 100. As we know that the efficiency is always denoted by, represented by percentage, and the output voltage, which is denoted as the voltage of an AC current, is defined as Vm into sine of 2 pi FCT. And let us know the second formula, which is DC input power. The, the DC input power is the product of beam voltage and beam current. So the beam voltage is denoted with V0 and the beam current is denoted as I0. Therefore, the power of an input DC current is defined as the product of V0 into I0. And the third formula is AC output power, where it is denoted as power of AC, which is defined as it is the ratio of 2 into V0 I0 x bar J1 of x bar to that of to the 2 pi n minus pi by 2, where x bar is having the value of 2.408, J1 of x bar is having the value of 0.52, and the combination of these two terms will give the result as 1.25, and where this n is the mode. And the fourth formula is the relation between beam voltage V0 and the repeller voltage VR, where the VR is where VR is defined as it is the ratio of 6.74 into 10 power 6 into F into L root of V0 divided by N, where F is the frequency and L is the length, and V0, as we know that it is the beam voltage, and N is the mode. Now let's solve one problem related to reflex klystron. So the problem is stated as a reflex klystron operate at a mode of N is equal to 2 with a beam voltage of 300 volts and a beam current of 20 microampere. signal voltage of V1 which is given with the value 40 volts, and now we should determine the output power, the input power and the efficiency. So let's see how to solve this. So the given terms are V0 300 volts, I0 of 20 into 10 power minus 3 ampere, as we know that the micro is nothing but 10 power minus 3, and the mode is given as n is equals to 2, and the standard values as x bar of J1 of x bar, we will give the value of 1.25. And first we should determine the output power. As we know that the reflex klystron will give the output as power of an AC current. So the power of an AC current, which is defined as it is the ratio of 2 into V0 into I0 into x bar of J1 of x bar, which is divided by 2 pi n minus pi by 2. As we given values can be substituted here, so the 2 into V0 value is 300, so 300 into I0 value is 20 into 10 power minus 3 ampere, so 20 into 10 power minus 3 brackets into the standard value is 1.25, so we will substitute here, and it is whole divided by 2 pi into the n value is 2 minus pi by 2. When we substitute and when we solve by using the calc, we will be resulted with the value of 1.366 watts. Therefore, the power of an AC current which is given by the reflex klystron is 1.36 watts. And the second question to be determined is input power. As we know that the reflex klystron will be given or will be fed with an input power as DC. So the power of an DC current is given as it is the product of V0 and I0. As we know that the given value of V0 is 300 volts and the given value of I0 is 20 into 10 power minus 3 ampere. So when we solve this, we will get the value of for the power of an DC current is 6 watts. And the last one is the efficiency. As we know that the efficiency is nothing but it is the ratio of output power to that of to the input power. So the output power, the PAC which is already been found and the PDC and that is also been found, we should just substitute here. So the efficiency nu is equal to 1.366 whole divided by 6 into 100. As we know that the 100 is here which represents the percentage, where the efficiency is always represented in terms of percentage. So when we use the calc and when we solve this, we will be resulted with a value of 22.76%. Now let's solve the second problem, which is stated as a reflex klystron operates at 8 GHz with DC beam voltage of 300 volts, a reply space of 1 mm for a 1 3/4 mode. Calculate the maximum output power, where which is denoted as P of AC, and corresponding rippler voltage for a beam current of 18 microampere. So the rippler voltage which is denoted as VR and the beam current which is given as I0. So the given terms are V0 which is 300 volts, I0 which is 800 microampere, as we know that the micro is nothing but 10 power minus 3, and the standard value is x bar J1 of x bar which is having the value as 1.25, and the mode is 1 3/4 mode, and which is a mixed fraction. Now we should find out the maximum output power PAC. So the maximum output power PAC is defined with the formula as it is the ratio of 2 into V0 into I0 into x bar J1 of x bar whole divided by 2 pi n minus pi by 2. Let's see how to solve. We should substitute all the given values in this formula. So 2 into V0 value is 300 volts, I0 value is 18 into 10 power minus 3 ampere, and the standard value is 1.25, which is whole divided by 2 pi into, As we know that the given mode is in mixed fraction, we can solve by using the mixed fraction rule, where the denominator is first multiplied with the given one and which is and the resulted 4 will be added with the numerator which is 3. So 4 plus 3 is 7 and the and the denominator should be written as it is. Therefore, the mixed fraction value will be given as 7 by 4. So we should substitute the 7 by 4 value in the place of n minus pi by 2. And when we solve these values by using the calc, we will be resulted with the value of an power of an AC as 1.432 watts. And also in the question they had also asked the corresponding repeller voltage for a beam current of 18 microampere. So the repeller voltage is defined as VR, where the denoted VR is defined as it is the ratio of 6.74 into 10 power minus 6 F into L root of V naught minus V naught whole divided by N. Therefore, the given 6.74 into 10 power minus 6 is written as it is, and the frequency in the question, the reflex klystron operates at 8 GHz and the F is also been given. So 8 into giga is nothing but 10 power 9 into the length. The repeller space is 1 millimeter. So millimeter is nothing but 10 power minus 3. Therefore 1 into 10 power minus 3 into root of V naught value is 300 whole divided by the mode value is 7 by 4 as we already solved it here, and which is minus by the value 300. When we solve this term first and when we minus the resulted value by 300, we will be resulted as 20 233.669 volts, which will give the value of an repeller voltage. Thank you.